Okay, so this is the second video that we've made on probability distributions. In the first video, we went through the key concepts that you need to know for this topic. In this video, we're just going to go through a bunch of past exam questions, okay? If you want to have a go at any of the questions yourself, just pause the video before I go through the answer. Just before I go through this question, I want to make one note quickly. The exam questions that they ask on this topic can be quite unusual and quite unique, and what I would recommend as a tip is when you've read through the question, just take a step back and reread the question carefully to make sure you fully understand it. Don't just jump straight into the question. Make sure you fully understand what it is asking you. Okay, so for this question, we're told a bias spinner can only land on one of the numbers 1, 2, 3, or 4, and the random variable x represents the number that the spinner lands on after a single spin, and the probability that x is equal to r is equal to the probability that x is equal to r plus 2 for r is equal to 1 or 2. And given that the probability of x is equal to 2 is equal to 0.35, we need to find the complete probability distribution of x for 2 marks. Now, there is a lot of information that's given to us in this question, so let's just take a step back and reread it, okay? Now, this first sentence here is really easy. This is just telling us we have a spinner, and the spinner can land on one of the numbers 1, 2, 3, or 4, okay? And we're told the random variable x represents the number that the spinner lands on after a single spin. So this is just saying that we spin the spinner once, and whatever number it lands on, this is what x is, okay? And the probability that x is equal to r is equal to the probability that x is equal to r plus 2 for r is equal to either 1 or 2. Now this here, it looks quite complicated, but what this is saying is this formula here is true for when r is equal to either 1 or 2. So let's just consider the two possibilities. Let's start for when r is equal to 1. So therefore this formula here is going to be the probability that x is equal to r, so x is equal to 1, is equal to the probability that x is equal to r plus 2, so this is going to be 1 plus 2. Okay, so if we simplify this, this is the probability that x is equal to 1 is equal to the probability that x is equal to 1 plus 2, which is 3. So the probability that x is equal to 1 is equal to the probability that x is equal to 3. So what this means in the context of the question is the spinner, if we spin it, the probability of it landing on 1 is the same as the probability of it landing on 3. Okay, now if we consider when r is equal to 2, so this is going to be the probability that x is equal to r, so x is equal to 2, is equal to the probability that x is equal to r plus 2, so this is going to be 2 plus 2. So this is going to be the probability that x is equal to 2 is equal to the probability that x is equal to 2 plus 2, which is 4. So the probability of x is equal to 2 is equal to the probability that x is equal to 4. So what this is saying is the probability of the spinner landing on 2 is the same as the probability landing on 4. Okay, so why is this useful to us? Because we know that the probability that x is equal to 2 is equal to 0.35. So the probability that x is equal to 2 is equal to 0.35. Now we know the probability that x is equal to 2 is equal to the probability that x is equal to 4. So the probability that x is equal to 4 is also going to be equal to 0.35. Now, for an event, remember, all of the probabilities added together are equal to 1. Now, if we minus the probabilities that we've already taken into account, so we know the probability of the spinner landing on 2 is 0.35, and we know the probability of it landing on 4 is 0.35. If you put this into your calculator, it's equal to 0.3. So this here is the probability we have unaccounted for. So this is going to be the probability of these two events here, the probability that the spinner lands on 1 and the probability that the spinner lands on 3. And we know that the probability that the spinner lands on 1 and the probability that the spinner lands on 3 are equal to each other. We know that when they're added together is equal to 0.3 because this is the remaining probability. So if we do 0.3 divided by 2, this is equal to 0.15. So therefore the probability that x is equal to 1 is equal to 0.15, and the probability that x is equal to 3 is equal to 0.15. And these here are the probabilities that the spinner lands on 1, 2, 3, or 4. Okay, so we need to show the probability distribution. Now, we talked about in the first video on probability distributions that there are quite a few ways that we can do this. The easiest way, in my opinion, is to do it via a table, okay? So the spinner can land on either 1, 2, 3, or 4, okay? Let's call these values here, let's call these R, and the probability that x is equal to r, so this is the probability that x, which is the random variable, is equal to each of these values. So the probability it's equal to 1 is 0.15, the probability it's equal to 2 is 0.35, the probability it's equal to 3 is 0.15, and the probability that it's equal to 4 is 0.35. And this here is the probability distribution of x. Okay, so here's another exam question where we're told the discrete random variable d has the following probability distribution, and then we're given this table here. So d can be equal to either 10, 20, 30, 40, or 50, and then the probability that capital D, which is the discrete random variable, is equal to d is given by these probabilities here, where k is a constant and k is in all of these probabilities here. And for part A, for 2 marks, we need to show that the value of k is 600 over 137. Now, the key to figuring out this question is to remember that the sum of all of the probabilities in an event are equal to 1. So therefore, all of these probabilities, k over 10 plus k over 20 plus k over 30 plus k over 40 plus k over 50, they are all equal to 1, and we can use this in order to find the value of k, okay? I'm going to quickly rewrite this like this here, where I've written this k over 10 as 1 over 10k, and then this k over 20 as 1 over 20k, and then so on, to make it a bit easier to show how we're adding these all together. So 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 40 plus 1 over 50, if you put it into your calculator, is equal to 137 over 600. So this here is going to be 137 over 600k, and this is equal to 1. So therefore k is going to be equal to, if we divide both sides by 137 over 600, it's going to be k is equal to 600 over 137, and this is the value of k. Okay, so the question goes on and it says the random variables d1 and d2 are independent and each have the same distribution as d. And for part B, we need to find the probability that d1 plus d2 is equal to 80, giving our answer to 3 significant figures for 3 marks. Okay, so let's just slow down and reread the question to make sure we understand what's going on. So we're told the random variables d1 and d2 are independent of each other and each have the same distribution as d. So d is this up here, so it follows this probability distribution. So this line here is saying that d1 and d2 are the exact same as each other. There's no difference between them. And d1, for example, follows this probability distribution here. So d1 can either be 10, 20, 30, 40, or 50, and it has these probabilities here, and this is the same for d2. And we need to find the probability that d1 plus d2 is equal to 80. So if we consider d1 plus d2 is equal to 80, once again d1 can be either 10, 20, 30, 40, or 50, and this is the same for d2. So we need to consider what pair of values of d1 and d2 in this table here add together to give 80. Now, if you consider this, you realize there are 2 pairs of values for which this could be the case. You have 50 here, and you have 30 here. So 50 plus 30 is equal to 80. So this is one possibility. Or the other possibility is that 40 plus 40 is equal to 80. There is no other pairs of numbers here that would add together to give 80. Now, if we consider this in the context of d1 and d2, so let's start with the 50 plus 30 is equal to 80. So here there are 2 possibilities for d1 and d2. So the first possibility is that d1 is equal to 50, and d2 is equal to 30, or the other possibility is the other way around, so d1 is equal to 30 and d2 is equal to 50. Okay, now if we look at this one here, there is only one possibility here, because both d1 has to be 40 and d2 has to be 40. So there are three possibilities for when d1 plus d2 is equal to 80. Okay, so let's consider the probabilities of these three scenarios. So let's start with this one here. So the probability of this scenario, we need d1 to be equal to 50. So the probability that d1 is equal to 50 is k over 50, and this is multiplied by the probability that d2 is equal to 30, and the probability of this is k over 30. So this here is going to be k squared over, and then 50 times 30 is 1,500. Let's consider this second scenario. So the probability that d1 is equal to 30 is k over 30, and this is multiplied by the probability that d2 is equal to 50, which is k over 50, and this is the same as above. This is k squared over 1,500. Okay, now let's consider the third scenario where d1 is equal to 40. So the probability of this is k over 40, and this is multiplied by the probability that d2 is equal to 40, which is k over 40. So this is going to be k squared over, and then 40 times 40 is 1,600. Okay, so these are all of the probabilities, so we need to add these together. So it's going to be k squared over 1,500 plus k squared over 1,500 plus k squared over 1,600. Okay, now if you put 1 over 1,500 plus 1 over 1,500 plus 1 over 1,600 into your calculator, is equal to 47 over 24,000, and then this is going to be multiplied by k squared. Okay, so this here is the probability that d1 plus d2 is equal to 80. So this is 47 over 2,400 multiplied by, and we know that k is 600 over 137. So k squared is going to be 600 over 137 squared. And if you put this here into your calculator, is equal to, it wants its three significant figures, 0.0376. So this is the probability that d1 plus d2 is equal to 80. Okay, so here's another past exam question where we're told the discrete random variable x has the following probability distribution, and then we're given this table here, okay? So we're told that x is equal to either a, b, or c, and the probability that this variable is equal to x is given by these probabilities here, so log base 36 of a, log base 36 of b, and log base 36 of c, where a, b, and c are distinct integers, and this is the order of their sizes, and all the probabilities are greater than 0. For part A, we need to find the values of A, B, and C for 5 marks. Okay, so this is worth a lot of marks, and this is quite a difficult question. Okay, now the key to this again is in an event, all of the probabilities added together are equal to 1. So that means that here, these are the probabilities. So it means that log base 36 of A plus log base 36 of b plus log base 36 of c, all of these probabilities added together are equal to 1. Okay, now if you remember the laws of logs that we talked about in pure maths, when you have 3 logs like this that are added together, you can combine them into one log by multiplying what are inside the logs. So this log base 36 of a plus log base 36 of b plus log base 36 of c, we can rewrite this here as log base 36 of a multiplied by b multiplied by c, like this here, and this here is equal to 1. And we can further simplify this, because if log base 36 of abc is equal to 1, we can get rid of the log and say that abc is equal to 36. Okay, so a multiplied by b multiplied by c is equal to 36. Okay, so we are told that a, b, and c are distinct integers, and a multiplied by b multiplied by c is equal to 36, okay? So we need to find three distinct integers that multiply together in order to give 36, and these could be the possible values of a, b, and c. Now, there are a few methods that you can use in order to get these three distinct integers. In the mark scheme, it talks about prime factorization, which you can do it that way if you want. The way that I just did it is I just scribbled down on a piece of paper three numbers that multiply together in order to give 36. Now, if you kind of go all the way with trying to figure this out, you find that there are actually four different ways that you can do this. There are four different ways in which three distinct integers multiply together to give 36, which are these here. So 1 times 2 times 18 is equal to 36, 1 times 3 times 12 is equal to 36, 1 times 4 times 9 is equal to 36, and 2 times 3 times 6 is equal to 36. Remember, the integers need to be distinct. So for example, you can't do 2 times 9 is equal to 36, because here you have two integers that are the same. They need to be distinct integers, so this doesn't count. And by the way, I'm not saying in the exam that you need to give all four of these ways in order to do it. Okay, you don't need to do that. I'm just kind of doing this for completion. Okay, now the correct answer for the values of a, b, and c, and the three distinct integers that multiply together to give 36, is this one down here. The reason for this is all three of these ones here have 1 as one of the integers. And the problem with this is, let's say for example that it's a is equal to 1. The problem with this is therefore the probability would be log base 36 of 1. Log base 36 of 1 is 0, and we are told that all the probabilities are greater than 0. So this can't be the probability, a can't be equal to 1, so neither of these three can be the answer. You can't have 1 as one of the integers. So this here is the only possible answer for the three distinct integers that multiply together to give 36. 2 times 3 times 6 is equal to 36, okay? Now, we are told that C is the biggest, and then B is the middle, and then A is the smallest. So therefore, we can figure out here that A is equal to 2, B is equal to 3, and C is equal to 6. And these are the values of A, B, and C. I accept that this is quite a difficult question. You have to kind of think about it quite a lot in order to get these three numbers here, but this is the correct answer. Okay, so the question goes on and it says the independent random variables x1 and x2 each have the same distribution as x, and for part B we need to find the probability that x1 is equal to x2 for 2 marks. So this is kind of similar to the example we talked about before, where x1 and x2 have the same distribution as this up here. Now we know what a, b, and c are now, so we can plug the values in. So a is 2, so therefore this here is going to be log base 36 of 2. We know that b is 3, so this is going to be log base 36 of 3, and we know that c is 6, so it's going to be log base 36 of 6. Now log base 36 of 6, if you put this into your calculator, is equal to a half. It comes out as a clean value. So this here is the probability distribution, okay? Now we need to find the probability that x1, which has this probability distribution here, and x2, which has this probability distribution here, we need to find the probability that x1 and x2 are equal to each other. So there are three possibilities for which this could occur. The first one is that x1 is equal to 2, and x2 is also equal to 2. So the probability of this, the probability of x1 being equal to 2, is log base 36 of 2, and this is multiplied by the probability that x2 is equal to 2, which also has a probability of log base 36 of 2. If you put this into your calculator, it's equal to 0.0374. So this is the probability of this here. And then the second way is that x1 is equal to 3 and x2 is equal to 3. So the probability of x1 being equal to 3 is log base 36 of 3, and this is multiplied by the probability of x2 being equal to 3, which is also log base 36 of 3. If you put this into your calculator, this is equal to 0.0940. And then the third possibility, I'm going to do it up here, is that x1 is equal to 6 and x2 is equal to 6. So therefore the probability of this is the probability of x1 being equal to 6, which is a half, multiplied by the probability of x2 being equal to 6, which is a half, and half times a half is a quarter. So the probability of x1 being equal to x2 is these probabilities added together. So it's 0.0374 plus 0.0940 plus a quarter, and if you put this into your calculator to two decimal places is 0.38. So this is the probability of x1 being equal to x2. Okay, so here's one final exam question. If you're having a go at the questions yourself, I just want to mention one thing quickly that we haven't talked about in this video, but we're going to talk about it in the next video on the binomial distribution. In this question, we have the phrases less than 2 and at least 2. Less than 2 means, if we're talking about x, for example, this means that x is less than 2, like this here. If we're saying at least 2, this means that x is bigger than or equal to 2. I just wanted to show you this quickly, that when we say at least 2, this means that x is bigger than or equal to 2. Okay, so for this question, we're told in a game a player can score 0, 1, 2, 3, or 4 points each time the game is played, and the random variable s representing the player's score has the following probability distribution where a, b, and c are constants. So this is this probability distribution here, and the probability of scoring less than 2 points is twice the probability of scoring at least 2 points. Each game played is independent of previous games played. John plays the game twice and adds the two scores together to get a total, and we need to calculate the probability that the total is 6 points for 6 marks. Okay, so this is worth a lot of marks. It's quite a long question, so let's just break it down slowly. Okay, I'm going to ignore this part at the end. Okay, we're going to come to this later. Let's focus on the probability distribution first. Okay, so in a game a player can score between 0 and 4 points, so 0, 1, 2, 3, or 4, and these are the probabilities here, with A, B, and C being some of the probabilities. Okay, and the probability of scoring less than 2 points is twice the probability of scoring at least 2 points. So what this line is saying is the probability of scoring less than 2 points, so the probability that S, which is the random variable representing the player's score, so the probability of scoring less than 2 points, so the probability that S is less than 2, this is what this is saying. And then over here we have the probability of scoring at least 2 points. So the probability that S is at least 2 points, so is bigger than or equal to 2, like this here. So these are the two probabilities. Okay, now the probability that S is less than 2, this is not including 2, is going to be these two scores here. So it's going to be these two probabilities, so it's going to be A plus B, and the probability that S is bigger than or equal to 2, so this is these three scores here, so it's these three probabilities, so it's C plus 0.1 plus 0.15, which is equal to C plus 0.25, like this here. Okay, so this is saying the probability of scoring less than 2 points, so this is the probability that S is less than 2, is twice the probability of scoring at least 2 points. So this is the probability that S is bigger than or equal to 2. So what this means is the probability that S is less than 2 is equal to 2 times the probability that S is bigger than or equal to 2. Make sure you have the 2 on the right side here. It's a very common mistake the students make, is they put the 2 on this side here. If the probability that S is less than 2 is twice the probability that S is bigger than or equal to 2, that means 2 times the probability that S is bigger than or equal to 2 is equal to the probability that S is less than 2. Make sure you get the 2 the right way round. Okay, and then what we can do is we can sub in these values here. So the probability that S is less than 2 is A plus B, and this is equal to 2 times the probability that s is bigger than or equal to 2, so we can sub this in. So it's 2 multiplied by c plus 0.25. If we expand this, it's going to be a plus b is equal to 2 times c, which is 2c, and then 2 times 0.25, which is 0.5. And I'm going to move this 2c to the other side. So it becomes a plus b minus 2c is equal to 0.5. Okay, so we have one equation here, and we can make another equation by knowing that all of the probabilities added together are equal to 1. So therefore a plus b plus c plus 0.1 plus 0.15 is equal to 1. If we simplify this, this is going to be a plus b plus c, and then 0.1 plus 0.15 is 0.25, and this is equal to 1. And then a plus b plus c, if you move this 0.25 onto the other side, it's 0.75. And here we have a pair of simultaneous equations. We have a plus b plus c is equal to 0.75, and a plus b minus 2c is equal to 0.5, and we can minus this one from this one, so therefore this a and this b and this a and this b will cancel out, and then c minus minus 2c is 3c, and then 0.75 minus 0.5 is 0.25. So therefore c is equal to 0.25 divided by 3, which if you put this into your calculator is 1 over 12. And therefore what we can do as a plus b plus c, which we now know is 1 over 12, is equal to 0.75. If we move this 1 over 12 onto the other side, we get that a plus b is equal to 2 over 3. Okay, so we cannot actually figure out the individual values of a and b. We just know that a plus b is equal to 2 over 3, but this is fine, we don't need to, okay? So the question goes on and it says John plays the game twice and adds the two scores together to get a total. And we need to calculate the probability that the total is 6 points, okay? So John plays the game twice. So let's say that S1 is the score in his first game, and let's say that S2 is the score in his second game. So he adds the two scores together to get a total. So this is going to be S1 plus S2. We're told that the total is 6 points, so S1 plus S2 is equal to 6, and we need to calculate the probability that the total is 6 points. So we need to calculate the probability that S1 plus S2 is equal to 6, okay? So remember, S1 and S2 can be equal to either 0, 1, 2, 3 or 4. So let's consider the possibilities for when S1 plus S2 will be equal to 6, okay? So the first possibility is that the score in the first game, S1, is equal to 4, and the score in the second game is equal to 2. This would mean that S1 plus S2 is equal to 6, okay? The probability that S1 is equal to 4 is 0.15, and this is multiplied by the probability that S2 is equal to 2. The probability of it being 2 is C, and we know that C is 1 over 12. If you put this into your calculator, this is 1 over 80, okay? The second possibility is that S1 is equal to 2 and S2 is equal to 4. The probability of S1 being 2 is C, which is 1 over 12, and this is multiplied by the probability that S2 is equal to 4, which is 0.15, and this is also 1 over 80, okay? The third possibility is that S1 is equal to 3 and S2 is also equal to 3. The probability that S1 is equal to 3 is 0.1, and this is multiplied by the probability that S2 is 3, which is also 0.1. If you put this into your calculator, this is 1 over 100. These are the three possible ways that S1 plus S2 can be equal to 6. So therefore the total probability that S1 plus S2 will be equal to 6 is these three probabilities added together. So 1 over 80 plus 1 over 80 plus 1 over 100, which if you put this into your calculator is equal to 7 over 200, or this is also equal to 0.035. This is the probability that S1 plus S2 is equal to 6, and this is the final answer.